Good afternoon, my name is Gary. It is a broiling hot afternoon here in Michigan. Temperatures begin with some really big number like an 8, and really too hot to be outside and do anything enjoyable, so come on into the shop and see if I can't get some work done. I've got this little piece of ductile cast iron here that I'm going to make something out of, and I'll show you in a little bit what it is. It's going to involve a little bit of lathe work to start off with. And thinking forward going through this project, I can already see a couple challenges with it. The first one is just simply how to put this thing onto the lathe, because normally you grab something, you pick it up. Every time I try to grab this, it slips out of my fingers. And if I grab it this way and mount it up against the chuck, well, I'll probably smash my thumb or something like that. So I was thinking about this a little way, but you look at a piece of material, I got lucky. I found out it had an eye bolt in it. And I'm going to be able to use that eye bolt as a way to get a little bit better grip on this. So I'm going to take this over to the lathe and chuck it up. But, well, maybe first I'll show you what I'm going to be doing with this. Maybe not. Now, what the heck. This is Ghidra, the three-headed monster. It's a Cincinnati Sonova 80 205-12 milling machine with an independent overarm spindle on it. So I've got horizontal milling capability and vertical milling capability. It is a universal mill, so the table pivots, and it has a lead attachment with a dividing head on it. So this is the reason I call it the three-headed monster. 1, 2, 3. And what we're concerned about right now is the horizontal spindle. Great for milling, but they've got another attachment that I picked up that I want to check out and see if I can't mount it on there. So this is going to require a couple parts, and most of the work on this is going to be lathe work. A couple things on the mill that we'll do, but the vast majority of the project is going to be lathe work. The first thing I did is I took some measurements of the spindle in that area, and I also cut out a template so that I could just check and, there we go, see how things lined up there. Mainly to just check my measurements out and so forth, and use it a little bit later in the project. So I've marked holes on here, got a center, and then I don't know if you can see them, but I've got a couple rings scribed around here. The larger one is 10 inches, which is the diameter of that small piece of cast iron that we're going to be working with. Now this is what we want to mount on the mill. Actually, maybe you want to see that side. This is a teal shaping attachment, and it has some instructions on it and so forth, but honestly, I don't know what it came off of. I don't know what it fits. What I'd hoped to get was a Cincinnati shaping attachment. When I bought the mill, I located one, didn't have the money right away for it, and about a year went by. I got on the internet, it was still listed, sent an email down to the company, and never got a reply from them, but immediately the listing was pulled. So one of two things happened. Somebody else just bought it out from under me the same day, or more likely they just really didn't know what they had in their inventory. So, well, they lost business. This came up on eBay 6 or 8 weeks later, and the price was really a lot lower. So I kind of looked at the pictures and kind of guessed at some dimensions on some things, held a ruler up to it, and said, you know, I think that I can make an adapter to mount it on my mill. So I went in and bought it. Kind of a gamble. Okay, thought cheap when I got it and got it in here to look at it. I said, yep, I think it is going to work. So the idea is we're basically going to build a cylinder out here, and it's going to have, you know, some holes inside of it to have clearance for the rotating parts here and the rotating parts on the mill, and we'll be able to bolt it directly to the column of the mill, and then we will here have T-nuts in slots so that we can bolt this in, and this will pivot, and then I'll have to make a driver. So basically I'll take a either make or I'll adapt an existing Cat 50 taper. You know, get out of here. Bees, they I don't particularly like them. Maybe because I'm allergic, I don't know. So anyhow, that's the basic process on this. I still have to kind of look around on this. The adjustments on it are kind of hidden down inside here, so adjusting length of stroke and things like that, I got to figure all of that out. Some of the others, you know, there's not a lot of external controls on this. This is clearly the position, the head of the slot. So I've got to work around to find out exactly how it works, but that's something I can do once I get it on the mill. So this is the project. Need to move over to the lathe and start setting things up. Now you want to lift something up out in the middle of nowhere. I always recommend just getting a sky hook. Now, put some boards down on the bed of the lathe, and the reason is, although you know we all know that any one of us can pick this up with one hand and not have any risk of dropping it, but Skyhook's only good for 500 pounds, so I'm going to just be a little bit cautious. This thing's, because you know, it probably weighs about 130 or something like that. It's 10-inch diameter, 6-inch long piece of 65, 45, 12 ductile wire. So if it is a little bit of a heavy bead, we'll just lift it up a little bit and swing it over into position. Move my cart out of the way and get it roughly in a line on the 4-jaw chuck. I'd already set the chuck jaws so that they were close to being in the right position to lock it down. And there we go, I got a little bit of tension on it. So, now what I'm going to do is just stack a couple boards up here so it can't go anywhere. A couple blocks under it, and then release the sky hook and lower it. Now my immediate concern is I don't want this thing falling forward, and you know, I planned ahead for that. Now the sky hook off out of the way. Carry it down. All I'm going to do here, just use the tailstock, the bullnose center in it, and it's just going to be there basically to keep the piece of metal from falling out and get everything else out of the way. I no longer need the eye bolt. It very conveniently was mounted in the side. Really have no idea how that got there. Yeah, right. You believe me, don't you? Now I need to center this on the 4-jaw chuck. This is as cast. Okay, so when this comes out, this is not a machine surface. It's not smooth. If I were to put an indicator on here and try to center this, this would be absolutely hopeless. So what I'm going to do instead is I'm just going to take a surface gauge, set it up on here on something, and just find some place along here where I can put it and get a needle up roughly against the thing, maybe at about the horizontal edge here. And it doesn't need to be too fancy. And then now I can spin the thing, and right there I see I've got about 1/4 of an inch out. A little thumping comes about because it's not tight. So I'll push it back in a little bit there with the tailstock. That is actually surprisingly good for a first guess. Oh, this can't happen. This is just too good. So I'm out about a 1/8 of an inch there, about a 1/16 of an inch there. Now the nice thing here is, this being just a little tiny 16-inch lathe, I can reach around both sides. But I'm going to pay a penalty for that in a few minutes. Put those down. Just touching there. Just off about 1/16. That's about an 1/8 off. Just a little more. I do believe I'm good, so I'm just going to snug them up as I go all the way around. Now, if you watch one of the pros doing this, you would have seen a great demonstration of skill. What you saw right here was a great demonstration of luck offsetting a lack of skill. I've got it tight. Should go one more time with the surface gauge. And for the benefit of my European viewers, it's about 1/2 millimeter off peak to peak. Also check it in close. There's really not much I can do about it. It's more of a curiosity thing than anything. Pretty similar. Okay, so I do believe we are ready to do a cut. So now I'm ready to do my first cut. I've got a board underneath that's there to do two things, just in case this pops out, is to protect the waves a little bit. But the main reason for having it there, and also for the cloth underneath, is just to catch some of these cast iron chips. It's cast iron, so I don't need any cutting fluid on it. I've already set up my tool. I've got a flat nose tool with a fairly coarse feed. Kind of figure I'll probably end up doing 2 passes on this, because the first one's going to be kind of minimal, and because we're going to get a little bit of an uneven cut. This blue stuff is just some of the glue from the shipping label back when I got this. So we should be turning this at a slow speed, and just a quick jog to test. I got it into low range. Okay, we're good. A little light to see what I'm doing. And we'll be feeding inward. And at a fairly fast pace, because I've got a flat nose tool on here and a cast iron going to give us a wide cut. This is a carbide tool. It's a C2 Chinese 2 grade, and I'm using it should be able to go, according to the chart, somewhere around 75 RPM. I'm running at 55 right here. And as you can see, this first pass isn't deep enough to get a full cut going in. So this catching, I am getting a little bit of vibration, a little bit of chatter on it. I expected that because the saw cut's not perfectly straight. But it's nothing that I'm worried about right at the moment. And hopefully this thing isn't going to prove me to be a liar. So let's just go around and see how we get out of this cut, and then we come back and see if we need to make any adjustments in the tool. All I'm interested in right now is getting this face flat and pretty much perpendicular to the long axis, although it doesn't have to be exact. All that's going to be taken care of later. And I know what I'm planning to do with this next, so we'll see that when the time comes. Important enough I don't need my ears. Okay, stop right there. I'll get over to the thin side now that I know where I am and take a couple little measurements here. So that's going into about 9. About 13. Okay, so I'm going to bring it out here. I'm going to set it at 20 thousandths. The last one was at about 18. And I'm going to tighten cross slide down. Confirm that I have the carriage tight. And try another cut. Chatter than I like. Slow it down a bit. Okay, I'm going to save that tool for the finished cut. Just turn in here. I'll rough this out with one of my high-speed tools. On this diameter, I do need to stay slow. Now this is going to be a little abrasive on the tool bit, but I'm not getting the chatter because this time I'm actually cutting on this lip, or cutting on the side going in. I'm not cutting on the face. Whereas the flat nose tool is really just plunging into the face. The edge of the tool doesn't have any rake on it, so it's kind of an ideal setup to get some chatter there. Here at least I'm going to get everything roughed out. Fortunately, it's just going to take some time. Let us see what we have. And this is a little bit of chatter that we had with the wide mount. Then we have an area that wasn't cut into going across. A couple thousandths raised, center there. reasonably smooth surface. It would be actually good enough for what I want to do. I want to get it faced the whole way across. Set that. I'm going to take maybe another 5 thousandths off of where that was. So sitting around 13, move it up to maybe 17 or 18. Now this thin cut ought to go through without too much chatter. That's what I'm hoping for. Make sure I get my speeds back down slow. Give it a shot at 35 first. Let's see how it behaves. That adjustment, bring the face parallel, seems to have worked. So I'm not getting any chatter now. What was happening was with that coming in this way with the lead angle on it, okay, setting up a large force this way with chatter. This way it's just going parallel with negligible outward force on the tool, pushing towards the tailstock, so I'm not getting in and out vibration anymore. So the lesson here is to learn sometimes the machine's trying to tell you something. Maybe you ought to stop thinking, shut up and listen. I'm not very good at that. That is a nice finish. Now let's talk about my other problem. Now that's the problem with having such a small lathe. I can't just run the carriage down to 6 inches because I don't have the gap distance here. It's only a 16-inch lathe, so it really can't handle things very big. And remember, 16-inch is measured down to the ways. Swing over the cross side is probably more like about 8-9 inches, something in there. Would like to turn this side. However, I do know one thing that's going to work in my advantage right now, and that is that I know that after about an inch or so here, the rest of this is going to be turned down smaller later, or at least it doesn't need to be the diameter it is. So all I'm going to worry about right now is just trying to get an inch trimmed here. So all I'm going to do here is I'm just going to take a cut maybe about an inch down the side, and just to make sure I get far enough, I'm going to mark it. So that's a little over an inch right there. So if I get to that mark, I know I'm good. Extend this compound down a little bit. I don't want it to overhang too far, but I want to make sure that I don't run the cross slide into the face. Loosen the lock. And the diameter here absolutely does not matter. I just want to keep it about as large as I can do it in practice, and maybe just get under just a little bit of scale along here just to get a decent finish. So maybe that looks like it might work. I'm just going to have to give it a try and see how it goes. Last thing to do is set my feed rate. I don't want to go with the super high speed that I was doing cutting across. This way I'll be 4 times as fast. Let me just check it. It should be about 15 or 16 thousandths per revolution. And since we're on high-speed steel, I'm going to slow it down to speed to 25 RPM. Recommended this diameter is a little bit less than that. It's about 19, but the lathe won't go that slow. But it's a shallow cut, and these tool bits are free. Well, not really free, but darn close to it. They'll last me forever since I'm not doing 40-hour-a-week work. So, it should work. And I'm getting a chip the whole way around, so it should be okay to go on down to my mark. And my plan is, this is the face that's going to go up against the face of the mill. There are going to be 3 slots around the side of it. And so this will be out here is the outside of the flange. It's going to bolt to the face of the mill. So this surface, I'm just turning it around to help me locate it for later machining. It is not a finished surface that does anything in particular. And it looks like I'm already got more than my inch that I need there. So at this point in time, I'm happy. I'm going to turn that down. And I am going to clean up for the night. It looks like this will be fine for dislocating. The next steps are going to be on the mill to drill a couple holes, because my plan, rather than try to hold this in the forge all the time and worry about it, or getting loose or anything for all the machining I'm going to do. I'm just going to put this straight onto a faceplate. I'll cut down a little bit of the excess overhang on the spindle. It'll bring things in closer, so the center of mass of this slug will move from here down to about here. Be a little less wear on the bearings, and it also will just guarantee there's just no way that it's going to come off. So we're going to go through that and take it over, locate the holes, and drill them. Those holes won't matter in the end because I'm going to have slots there, and when I finally mill those slots in, they're going to end up removing the holes. But for right now, I'm going to use some holes to just help me do some locating and hold this onto here. So it's time to clean up for the day. It's getting way too hot out here. All my non-ferrous metals are starting to melt, and I need to get inside and find a way to cool down. So let's have a good evening.